So the purpose of the game now is to write a function for Matlab that sets a given matrix to 0, to the 0 matrix, one column at a time. So before we get started, let's get set up. Here we have Matlab. Okay, so the first thing I want you to do is go to subdirectory programming. And in that subdirectory, what I want you to do is create a new subdirectory week 3. So let's say new folder, and let's call that week 3. And that's going to be the directory in which we're going to put all of our programming assignments for this week. The next thing I want you to do is to make sure that you have the algorithm that sets a matrix to 0 handy. And that's figure 3.1 in the notes. So let's put that right here. And then to implement that, we're going to use the Spark web page. So I've gone ahead and made sure that I had that handy and set up. And here's the Spark web page. And what we're going to do is we're going to implement this algorithm on the left with the Spark web page. And let's see, we decided, I think, to call this 0 matrix, the routine. It will be an unblocked algorithm. What a blocked algorithm is, we'll see later in the course. Oops. We're not going to give it a variant name. And notice that there is only one operand, namely the matrix A. And we're going to want to march through that matrix from left to right because we're going to set the columns to 0 one at a time. And that matrix is going to be both input and output. So on the right now, we have our code skeleton. And we can grab that, copy it, and then what? And then we want to go to our Matlab session, and we will want to say create a new function that sets up the editor, and we'll just delete all of that and now paste in the function that was created by the Spark web page. And if we move this over a little bit, then we can put this next to the algorithm on the left. And what's left to do is to fill in these lines right here. Now what we want to do is set a1 to 0, but this would just create a variable that is equal to the integer 0, and that's not quite what we want. So instead we're going to use the routine laugh 0v, which takes as input a1, that tells us how big of a vector we want to set to 0, and then returns a vector of that size and shape. And bingo, we're done. So we save this. So we'll save that in week 3 as in file 0 matrix underscore unblocked. It'll have a .m at the end. So if you now look here on the left, under week 3, you'll see the 0 underscore unblocked.m. And you have to make sure that you're in that directory, because otherwise it won't find that file. So then we can go over here, and let me quickly show you how to create a random integer matrix. So we can say a is equal to, and we can call the function rand_i, which creates an integer array with entries chosen randomly from -2 to 2 in this case, with 5 rows and 4 columns. And notice that now we get this matrix right here. And if we then call our function with that matrix, back comes a 0 matrix with 5 rows and 4 columns. Now, you probably still are trying to learn how to interpret this particular algorithm on the left and or its implementation in Matlab on the right. And for that reason, we created something very special for you. Okay, we created a tool that we call PictureFlame. Now, a link to that particular web page is in the problem. And if we now go to it, you see something that looks like this. Now, what is this? This is a very simple interpreter written by a colleague of ours, Semeng Lo, who is now a researcher at Carnegie Mellon University. that is specifically written to interpret the functions that we create in this course. So what we can do is we can go into this window, we can wipe out everything that's there, we can then go to our Matlab session, we can select everything in our editor, we can copy it, so I just hit the copy key, and then you can go into PictureFlame and you can paste it. So I've just copied over this function here, and then I can say load program, which does two things. One, it kind of simplifies what's there. It got rid of the function name and it got rid of a few other things, but the essence of the function is still there. And also on the right, it created a random matrix, in this case a 5x5 matrix. And now what we can do is we can execute this function that we just wrote by hitting next. If we say next, in red you get to see what part of the function is being executed. So this here says take matrix A, partition it into a left part and a right part where there are 0 columns in the left part. So that puts this thick line right here in the matrix. Next, we check whether we're done, which we're not. We then go and we repartition. Notice that this is now highlighted in red, and that partitions off the next column. Then it sets the next column to 0. Notice that in red it highlights what part of the matrix is being updated. Then it moves the thick line forward. That's the continue with here. And then it goes back to the top of the loop. It checks whether it's done. It repartitions again. It sets to 0, moves forward, and you can now see how we march through the matrix together with what part of the function is being executed. And this gives you a visual idea of what's going on in our function. And if you want to see it again, you can simply say reload. And if you don't want to keep clicking next, you can hit play and it'll automatically animate. Okay. And if you want to enter a new function, then you just hit new program, and then you can wipe out what's there and put a new program in. So we created this so that you can visually see what it is that the functions that you write actually do. Okay, well, that's it for this particular programming assignment. The next one you get to do partially on your own.